In this video, we'll be having a look at what's known as quadratic regression. Now, if you're watching this video, you really should already know how to do simple linear regression. I have a video there, and if you don't know how to add in data analysis tool pack, then you'll want to go back and watch that simple linear regression video. Alright, so I've got some data here. We have the number of servers, perhaps they're working in a restaurant or a drive-in, and then we have the number of orders taken by these servers. And we see that as the number of servers increases, we see, generally speaking, it looks like the number of orders is going up, which, seem likely. What I'd like to do first is simply do a scatter plot of the data. So I'm going to select all the data, including the headings here. There are several ways of doing this. You can actually use this little icon here, but I prefer to go up to the top and choose the Insert here. Click on Insert, and then you'll see Charts. And what I want is a scatter plot, and it's very easy to pick out from this listing here. So for the scatter plot, I'll click on that. Now, notice as you move around, you'll see the various difference that will be reflected in the graph down below. I just want the one with the dots, so I'll click on that, and let's focus on that. So we see here along the x-axis, that is a number of servers increases, the number of orders also increases. But you might notice that it doesn't really look like a straight line would fit the data very well. It would appear that as we go to the right, we're getting a steeper slope here, kind of a curvature like I'm tracing out here. Now, curvature in mathematics can be introduced in several ways, but the easiest is to add an x-squared variable. So if we look back at the data here, the number of servers is x, and it's being used to try to predict the number of orders, which is y. So what I'd like to do is add an x-squared column to the data. So let's just click on column B, and we'll do Insert, and it'll move it over to Insert a column. And so in column B, I want to have an x-squared column there. Now, in real life, it doesn't really seem to make sense to talk about servers squared. I'm going to type it in there. But understand that mathematically, using x squared or servers squared is just going to help model the curvature here in this scatter plot. So we'll fill this out. We have to square each of these numbers here in the x column. We'll let Excel do that for us. So I'm going to do equal. I'll click on the x value to the left. I'll use a caret for raising to a power. You can do Shift, the number 6 on your keyboard to do that, and then 2. Well, 1 squared is 1. But if we take and drag that down, we get all the way down to 10 squared is 100. Once again, the reason I did this is because I didn't really think that a straight line would be the best fit to the data here. So in practice, doing a scatter plot is often a very good way of making decisions as to what should follow. Alright, so next I'm going to use my regression tool. So I come up to the top to Data. Now because I've done the add-in, I can click on Data Analysis. And you might have to scroll down to find it, but I want this regression. I'll click OK. So what do I need to do now? Well, first off, my Y range would be orders. So start with the word orders and go down. You might be tempted to also select Y, but then you would have two labels, and Excel gets confused by that. So now for the input X range, I want servers and servers squared. So I'll select both those columns at once, like so. Again, I have labels checked because I included the verbal description here. And output range, last time I did a problem I had on an A16. That looks just fine. That should be below everything. So we'll click OK. And what do we get? Well, we get our regression output here. So let's have a look at it. I'll kind of add some spaces here. 12 observations. Double check that to make sure we had 12 lines of data. We did. All right. Now, here's what we want to focus on. Down here we have our coefficients right here. I'll draw some attention to those. Our intercept, that's a y-intercept, that would be 34.74. Basically, if you extended this data over here to the y-axis, it's saying that it would be at about 34.74. Now, it doesn't look like that from the picture. We'll have to see why. Now, our servers has a coefficient of -15, and our server squared has a coefficient of about 3. So, let's use this to try to make predictions. So, imagine that I have a certain number of servers, and what I'd like to do is predict the number of orders. Okay. Didn't really want that in yellow there. Okay, so make a little chart here, we will. Okay. How I somehow got things justified differently. But here we have servers and we have orders. Okay. So, for instance, if we wanted 8 servers, we would type the number 8 in here. Now, let's do our formula here for orders. Keep in mind, orders is y. Y equals, so type an equal sign. It equals the intercept, so you can simply click on that. Click on the intercept, that is in B32, plus, then it will be, you'll click on the coefficient for servers, which will be that cell containing the -15, and that will be times, and it'll be times servers. But what servers? Where do we have servers? We have it in this empty cell here. Okay, so click on that empty cell. And then finally you would have plus, and then you would have the next coefficient, and it will be times, now it's going to be times server squared. So where's servers? Well, it's the cell right above here again, that, and then raise that to the second power. Okay, so it's intercept plus this coefficient times servers plus this coefficient times servers squared. So now when I click OK, I've got a 34 there. But you know, this model isn't actually useful with 0 servers. You have to have a positive number servers. So, you know, technically this is with that being 0, but that really has no real meaning. I mean, you wouldn't have any orders really if you had 0 servers. So you do have to put in a non-zero number here for it to work. So for instance, let's just try 7 servers here. And what will it give us? It'll tell us that the predicted number of orders would be 72, almost 73 there. So just like simple linear regression, we don't interpret this as being an exact answer. We're saying that if we fit a certain model to the data, this would be our predicted value. It's useful to have a predicted value even though you know that, you know, it's not like it's 100% reliable. So that's what regression does. If we look at this, if we had tried to use linear regression, we may have gotten, a reasonable answer, but especially as we get higher, we see this curvature becoming more pronounced. So for instance, let's try doing the number 9 for servers. Let's say we have 9 servers. We click OK, and that's saying that it would predict about 138 orders. 9, 138, you might notice that this actual point is a little bit higher, but again, our model is taking all the data into account to make this prediction. Okay, I'm going to sign out here. Good luck, folks.